Hello, Honors Algebra 1. It is Wednesday, May 6th, and we are talking today about section 12.7, direct and inverse variation involving squares. Okay, so we have already talked about direct and inverse variation. I believe it was back in chapter 8. And so I went ahead and wanted to review this with you. And so here's direct variation, the first thing we're talking about here. And you remember that is y equals some constant times x. It's a linear equation, k is your slope. And if you're especially doing a word problem, you can simply set it up as a proportion. Y1 over x1 equals y2 over x2 and solve for your one missing variable. They'll give you the other three. Inverse variation, we move the x to the denominator, and y equals your k, your constant of proportionality, divided by x. Or if you want to set it up, if you've got a word problem here also, x sub 1, y sub 1 equals x sub 2, y sub 2. The product of x and y are always a constant, where in direct, the quotient of y over x is always a constant. Now we're going to discuss quadratic variation, since we're in the chapter on quadratic equations. And we're going to talk about quadratic variation for direct and indirect variation. So let's start out by talking about quadratic direct variation. So if we see the phrase y varies directly as x squared, or y is directly proportional to x squared, we're talking about quadratic direct variation. And here are our two equations we can use to set it up. The first one is, instead of y equals kx, it's simply y equals kx squared. And if you make a proportion, it's y over x squared equals y over x squared. Now, your homework today is the examples are not word problems. You can go back and look at those. But, and I like to use, let's see, I like to use, there's two solution methods, solution 1 and solution 2 for both examples in the book. I like to use solution 2 using your proportion or setting your products equal to each other. You can go back and look at those. It's just like we've done before, but with a squared term. So let's go ahead and look. I chose to go ahead and look at two word problems, since your homework is going to be word problems today. So let's look at the first one, the example. The price of a diamond varies directly as the square of its mass in carats. If a 1.5 carat diamond costs $2,700, what is the mass in carats of a diamond that costs $4,800? Well, I'm going to go ahead and first set up my basic equation. It says the price of a diamond varies directly with the square of its mass. So there we have it. The price is some constant times the mass squared. Now, since I'm going to go ahead and be looking at two different scenarios here, I'm going to go ahead and use my proportion method. That's my favorite. And I'm going to go ahead and set the first price over the first mass squared is equal to the second price over the second mass squared. Now, the first price was $2,700. And the mass that goes with that is 1.5 carats, and that's going to be squared. Now, we know the price of the second diamond is $4,800. What is its mass? And so here, I've got a mass, and I've got to square it. Don't forget that. Don't forget to square it. Now, I'm going to cross multiply. Oh, great. Come back. 2,700 times my mass squared is equal to 1.5 squared. Let me write that. 1.5 squared times 4,800. And so my mass squared is going to equal, well, I'm going to go ahead and take 1.5 and go ahead and square it. That is 2.25 multiplied by 4,800 divided by 2,700. Okay, now remember, we're solving for the mass squared. So when I multiply 2.25 times 4,800 and divide that by 2,700, I'm going to get 4. Now don't put 4 carats, because 4 is the mass squared. So the mass, we're going to take the positive root. This equation has two solutions, plus minus 2, but it's a word problem, and you can only have a positive weight in carats. And so 2 carats would be the mass of that more expensive diamond. Okay, now let's move on to inverse variation. So here we have, you would see written y varies inversely as x squared, or y is inversely proportional to x squared. Both of these phrases mean inverse variation. And our new equations are, in general, y is k over x squared. But if the constant is, my k value is always a constant, then I can just simply multiply y, excuse me, x squared times y, and your first x squared y pair will have the same product as your second x squared y pair. Now let's look at another example here. The exposure time needed for a photograph is inversely proportional to the square of the radius of the camera lens. So I'm just going to write a general equation for that. The exposure, is inversely proportional to the square of the radius. If the lens radius is 1 centimeter, the exposure time is 1/100 of a second. Find the radius of the lens for an exposure time of 0.0025 seconds. Okay, now what we can do here is, I think this is the quickest way to do it, the easiest way to set it up. Let's set our XY products equal to each other. So in other words, the exposure times the radius squared from the first information, the first pair, is going to be equal, have the same constant value as the second exposure and the second radius squared. So let's go ahead and fill these in. The first exposure time was, let's go back and look at it, 0.01 seconds. And the radius that went with that was 1 centimeter. So that's 1 squared. Well, that's easy. Now, find the radius if the second exposure time was 0.0025 seconds. And I've got to find the second radius. So I've got my r squared there. You can put r sub 2 squared if you want to, but since r is the only variable there, I'm just going to leave it plain old r. Okay, well, so what I have here is, oh, I've done it again. Oh, fun! Yes, okay. Now, I've got 0.01 times 1 is equal to, I'm going to go ahead and divide both sides by 0.0025. I think you can handle that. Equals r squared. And when I take 0.01 divided by 0.0025, I get the same answer I got in the first example. R squared equals 4, so my radius is going to be the positive square root. It's going to be 2, and my units are in centimeters. So the radius of that lens is going to be 2 centimeters. So nothing too earth-shattering today. We're just going to square one of the variables when we talk about direct and inverse variation. Okay, so that's your lesson for today. We've got one more section in this chapter and then we are done. So we will have our last test early next week, and one of your 3 tests will be dropped as usual. Even though it's open book, I'm going to go ahead and do that because I think you've been at a little disadvantage with me not being in class, being able to answer more questions because I haven't seen too many of you at Zoom. So anyway, I hope you do well with this. And there's a self-test for homework today, but that does not mean we're having a quiz tomorrow. We're going to wait and have one more quiz after we finish the chapter on the last 4 sections. Okay. Have a blessed Wednesday, and I will talk to you soon. Bye-bye.